Hello everyone, this is Mir Shabir. You are watching Vibrant Institute of Mathematics. Before starting our topic, let me tell you, please subscribe our channel and press the bell icon for the latest updates. Now today's topic is on Legendre's differential equation, linear differential equation with variable coefficients. So this is lecture number 2. Today is numerical practice on Legendre's linear differential with variable coefficients. Now before talk about the Legendre's differential equation, this lecture is very important for GATE aspirants too, because we are dealing with the Legendre's linear differential equation with variable coefficients. Now I will use simple this concept. So first of all, I will make use of the previous lecture. We will take elements. First element is putting the value of this coefficient. Here is the coefficient. What is this? Coefficient of this. This is 3x plus of 2. I will make this 3x plus of 2 here. This is equal to e raised power of z. Or finding the value of z is equal to, this becomes log of, this is 3x plus of 2. This is z is equal to log of 3x plus of 2. Again, you can find the value of x here by putting the value. This is here equation number 2. This is first equation. Let it be, this is here first equation. If you will find the value of x in this first equation, you can transfer this plus 2 in the right hand side. It becomes this one from first. I can write here from first again. This is 3x plus of 2 is equal to e raised power of z. 3x is equal to e raised power of z minus of 2. E raised power z minus of 2. So this is the value of x is equal to 1 divided by 3 times of e raised power of z minus of 2. So memorize this concept. This is x is equal to 1 divided by 3. This is an element. We will use this element in our numerical. I take x is equal to 1 divided by 3 e raised power of z minus of 2. Now the previous lecture says, when you numerically, this is a message for each and every student who want to learn this Legendre's linear differential equation in short technique. But I can use the short technique here. When you have got a coefficient 3x plus of 2, you just compare with this is bx plus of a. The coefficient is here bx. In front of x there is 3. In front of x there is b. So you just compare this given coefficient in the numerical and this bx plus of 3. It implies something. So in front of x there is b. That means b is equal to. In front of x there is 3. That means b is equal to 3. So here is only in the second term it contains a, and here is the constant a 2. So that means when you compare this coefficient and this one, I underline this one. So this is the short technique. We will find the values of a and b. Memorize this concept. This is the technique to find the values of a and b. Now first this is the content. I say I must use those contents in the numerical. This is the introduction of the numerical. I will use first numerical. This is, I will use the coefficient 3x plus of 2 whole square d2y by d of x square. So it becomes here, I always use b square into d minus of 1 into y. B square. You see in the previous numerical, previous lecture, this is b square. What is b here? B is 3. You insert here b is equal to 3. So it becomes here 3 square. What is 3 square? 3 square is 9. I can rub here and write direct 9. This is 9 here. So it is so simple idea. Now this is when you see 3x plus of 2 whole square d2y by d of x square, you can write 9 times of d into d minus 1 into y. So simple. Now second one, by decreasing order we can write 3x plus of 2 with powers. This I can write 1 here. This is dy by d of x. When you will see, previous lecture says it is b into d into, sorry, d is d or d into y. What is b here? B is nothing but is 3. Insert here b. Value of b, this is 3. So it is so simple. This is the I say third element. This is second element, and this is first element. This is 3x plus of 2 is equal to e raised power z. So this is first. I can take this one into box. I will use this one. This is second element. I will use this one in the numerical. This is x square. I will use this 2. This is 3x plus 2 into dy by dx equal to 3 into d of y. And I will use this box too. This is the value of x is equal to 1 divided by 3 e raised power z minus of 2. Memorize those elements. Now I will use inside the numerical. Numerical is this, I must substitute all such boxes inside this numerical. This is transformed into a new numerical. That means this linear differential equation with variable coefficients is completely transformed into a new differential equation. That is a differential equation with constant coefficients. That is our motive, to change this differential equation into a constant coefficients, a differential equation which contains a constant coefficients. Now I will substitute this. We can replace 3x plus up to whole square d2y by d of x square by this one. This is 9 times. I can substitute the values of this is 3x plus of 2. I can write first of all this is d2y by d of x square, comma this is 3x plus of 2 into dy by d of x, and as comma I will write the value of here x, the value of x in star. I let this equation, this is star equation. I let this is star equation. I substitute all such values in this star. Let us see, it is transformed. So we can write 3x plus of 2 whole square d2y by d of x. I can use this one. I will take this one, this box. Its right hand side is here. This is 9 times of d. This is d into d minus of 1 into y. So simple idea. It is now completely transformed into this. Now I can use this 3 here as it is plus of 3. I can write 3 plus 3. Now this is the line here. This one. This circle 3x plus of 2 into dy by dx. Why is this is here in this box 3x plus of 2 dy by dx. It is 3 into d of y. You can write this is 3 of d of y. Now the last term in the left hand side, this is 36 of y is as it is, equal to some quantity. What is this? This is 3 times of x square. I can write 3 times. I can use this equality here. 3 times of x square. Where is x? X is here. We can write 3 times of x square. X square is this one. This is 1 divided by 3. This is long box. I will bracket. I will take. This is here e raised power of z minus of 2. This is whole square. This is the value of x. Now again we will take second term 4x. I can write here. This is plus 4 times of x. Where is x? X is here 1 by 3 e raised power z minus of 2. I can use and paste here this one. This is 1 divided by 3. This is e raised power of z minus of 2. This is second one, and last and final term is plus of 1. I can write again this is plus of 1 here. This is plus of 1. So I will simplify this one, this concept. Here is y, here is y, here is y. We'll take common y. This becomes 9d into d minus of 1. Plus 3 into 3, 9. 3 into 3, 9. This is d. This is minus of 36. This is here. We will take y common from each and every term in the left hand side. So right hand side is here. We will calculate this concept. This is 3 square is 9 into 3 and 3 cancel out. There remains only 1 divided by 3. This is e raised power of z minus of 2. This is minus 2 whole square. This is plus this is 4 ones are 4 by 3. This is e raised power z minus of 2. This is minus of 2 plus of 1. This is plus 1 is as it is. This is separate. Now I will rub up here and continue as it. Now I will continue here. This is I can write this is 9d into d minus of 1. This is d minus of 1. This is plus times of 9 into d. This is 9 into d minus of 36 into y. When you take a copy and a paper and swallow this one, this will be converted into this concept. This is 9 times of d square minus of 4. This is into y is equal to 1 divided by 3 e raised power of 2z minus of 1 divided by 3. This is like this. When you calculate this concept, it is transformed into 9 into d square minus of y into y, d square minus of 4 into y. When you simplify this one, this idea, this right hand side, is converted into, it is merged 1 divided by 3 e raised power 2z minus of 1 by 3. Now finding this is the result. This is the differential equation. It contains completely constant coefficients. So let's you know that betterly. You know that whenever you have got a differential equation, linear differential equation with constant coefficients, so you know that the solution of that linear differential equation contains two components. First is the complementary function and second is particular integral. First of all, we will find the complementary function for this. So the complete solution, the auxiliary equation of this double star, let it be, this is double star equation. Double star is as, so complementary function is equal to, this is here, first of all, double star equation, the auxiliary equation of double star is as, means you just putting the value of this thing. This is d square minus of 4 equal to 0. You will get the value of d square minus of 2 square. You can write 2 square here as the values of 2 square is 4. So you will find the values of d is equal to plus minus of 2. Plus minus of 2. Clearly, we will let this concept, this is m1 is equal to 2, m2 is equal to minus of 2. You know better here, m1 clearly m1 is not equal to m2. m1 is not equal to m2. I will rub here this one, this is m1 is not equal to, you know better, whenever m1 is not equal to its complementary, lecture number 2nd. Therefore complementary function c dot f is equal to c1 of e raised power m1 of z, because there is a variable z, plus c2 of e raised power m2 of z. Insert the values of m1 and m2. What is m1? m1 is 2, m2 is equal to minus 2. Substitute here, this becomes complementary function is equal to c1 of e raised power, this is 2 of z plus of c2 of e raised power minus 2 of z. Now, but our given differential equation is in variable x, not in z. Now I will completely transfer this complementary function in terms of x. So I can write here this complementary function c dot f is equal to, or we can write, this is here c1 of e raised power, I can write in next form, this is c1 of e raised power, for the sake of simplicity I can write this is whole square plus of c2 of e raised power z whole raised power of minus of 2. Now I will replace, when you multiply z into 2, this becomes 2z. When you multiply z into minus 2, it becomes minus 2z. That means, where is e raised power of z? E raised power z is this one. When you see e raised power z, you can write 3x plus of 2 again. So it is completely transformed in terms of x. This is c1 of e raised power of z. Where is e raised power z is this, you can write 3x plus of 2 whole square. Whole square is as it is. Plus of c2. Where is e raised power z? Again, e raised power z is 3x plus of 2 whole raised power of minus of 2. Now you find this complementary function is c1 of 3x plus of 2 whole square plus c2 of 3 of x plus 2 whole raised power minus 2. This is the complementary function. We will use this concept. You just take this box as it is. Now we will find the particular. I will rub up here. मैं थोड़ा सा rub कर लूँगा यहाँ से. Is particular integral is equal to 1 divided by auxiliary polynomial multiplication of right hand side. What is auxiliary polynomial in this given differential equation? That contains, this is 9 times of d square minus of 4. I will write this differential equation required one. This is 9 times of differential equation which contains constant coefficient is of the form this 1 divided by 3 e raised power of 2z minus of 1 divided by 3. This was our required differential equation, which was linear differential equation. This is LDE, linear differential equation, which contains constant coefficients. I use this one. This is 1 divided by auxiliary polynomial. This is auxiliary in front of y. It contains 9 into d square minus of 4. I'll write it. Multiplication of right hand side. What is the right hand side? This is 1 divided by 3. I will write complete e raised power 2z minus of 1 by 3. This is as it is. This is 1 divided by 3 e raised power 2z minus of 1 by 3. Now you know that. You can multiply the concept. This one you will multiply both. This is 1 divided by 9 3s are 27 times of this is d square minus of 4 is as it is. And the right hand side is e raised power of 2z. This is minus, this is 9 3s are 27. This is 27 times of this is d square minus of 4. Here is no concept, I say no function. So I will make this a constant function. Rather I can write e raised power of 0 times of z. Why? Whenever you see a situation like this, you can write e raised power 0 times of z. So now you can use as per the rules or concepts, lecture number 3rd, whenever you see exponential function here, you can write d is equal to coefficient of z is 2, you can write 2. आप जहां पर भी देखेंगे लेक्चर नंबर 2nd, वहां पर जो एक्सपोनेंशियल रूल है z के सामने को वेरिएबल के सामने जो भी कुछ होगा वहां पर वही लिखना होता है. You can write the value of the coefficient of z in front of z there is 2, you can write the value of d is equal to 2. In such situation you can write similarly d is equal to, in front of z there is 0, you can write g is equal to 0. We will see that the concept is becomes 1 divided by 27. This is d is 2 square is 0, sorry, it becomes 2 square is 4 minus of 4. This is e raised power of 2, that is as it is. This is minus 1 divided by 27. This is here, when you insert the value of 0 here, it becomes here only 27 multiplication of this minus 4. This is minus 4. E raised power of 0 is 1. Don't write now e raised power of z, 0 times of z. It is obviously 1. So you can write d is equal to 0. D is 0 here. 0 square is 0. There remains minus 4. You can write here minus 4. And you just multiply the things. 4 into 27 and minus is plus. You can write this is 1 divided by 27. Now I will rub first and write here. 1 divided by 27, I will take common this one. This is 1 divided by 27. This is multiplication. But the concept is here 1 divided by 0. This is 4 minus of 4 is 0. This is e raised power of 2z minus of minus is plus. This is 1 divided by 4 only here. So but the concept here is denominator tends to 0, that this one term tends to infinity. This term tends to infinity, but this is finite. 1 by 4 is as it is. For this is known as case of failure. I can write here the right case of failure. This is case of failure. So you know the better that whenever this thing happens 1 divided by 0 means this term tends to infinity. This term tends to infinity. That means you can differentiate. You have put it the value d is equal to 2 here and this thing happens. But you will take this step here. मैं ऐसे कहूंगा यहाँ पर जब भी हमारे पास d का वैल्यू हमने सब्स्टिट्यूट किया तो हमारे पास इसका डिनोमिनेटर जो है it tends to infinity, it tends to 0, but the whole term tends to infinity. In that very condition you must differentiate. This is here known as case of failure. You differentiate here. Only this term is finite, second term. Only this term it tends to infinity. So we will differentiate here. So we will take wherever this thing this is the case of failure. You will take first of all the variable. What is the variable here? This is in terms of z. You can insert here z, and then you can insert this thing 1 divided by 27 is as it is. This is d square minus of you can differentiate this denominator. Differentiate with respect to d. D square has got differentiation 2d, and 4 has got differentiation, the constant, it is 0. We can write here 2d. This is here 1 divided by 2d. This is 2d, and exponential is as it is 2z. And what is the value of in the right hand side? Sorry, the second term, this is plus of 1 by 4. This is 1 by 4 is as it is. It is so simple idea. So you can write here this is 1 divided by 27. I have taken this 27 common. I will take 27 out of this box. This is 1 divided by 27. This is box here. I will take this one. This is 1 divided by 27. I take it common. This is I can write. I will continue. This is 1 divided by 27. This is z divided by 2, and 1 divided by d is integration. This is e raised power 2z. This is here 2z. This is d of z. This is plus 1 by 4. I can write 1 divided by 27. This is z divided by 2. What is the integration of e raised power 2z? This is e raised power 2z, but you will take power, differentiation of power is 2. You can multiply that 2 with this 2, it becomes 4 here. This is plus times of 1 by 4. I can solve here this particular integral here. This is particular integral is equal to this is 1 divided by 27 is as it is. This is this becomes only here z into e raised power 2z whole divided by, I will take 4 here plus times of 1. I can write this into this form, and you will multiply 4 with 27. This becomes 108. This is z into e raised power 2z plus of 1. So this is the particular integral. I will rub up here first. Now particular integral is equal to 108 Now you know that better because we're given a linear differential equation with variable coefficients. Legendre's linear differential equation contains the variable x. That means our particular integral is in terms of z. Now I will convert z in terms of x by using the concept. This is here. What is z here? Z is equal to, this is we can write z is log. This is first of all I will make it simple. This is z e raised power of z whole square. I can write e raised power 2z as e raised power z into whole square. E raised power z whole square plus of 1. But the concept is this one. This is particular integral is equal to 1 divided by 108. What is the concept of e raised power z? E raised power z is nothing but is 3x plus of 2. 3x plus of 2. 3x plus of 2. Whole square. This is whole square. This is as it is. What is the value of z? This is log of 3x plus of 2. This is log of 3x plus of 2. Plus of 1 is as it is. So I treated this in terms of x. This is in terms of z. This is in terms of x. Now you know that this is the required particular integral. This is particular integral. This is the complementary function. Now I will add both boxes. Thus the complete solution. Thus the complete solution of star is as. What is that? This is y is equal to complementary function plus particular integral. Complementary function is this c1 of 3 of x plus of 2 whole square plus c2 of 3x plus of 2 whole raised power minus 2. This is particular integral plus times of 108. This is 108. This is 108. This is here log brace 3x plus of 2. This is whole square. This is log of 3x plus of 2. This is plus of 1 is as it is. This is plus of 1 is as it is. So this is the required solution for the given numerical. The procedure is only one. I say it is so simple as Cauchy, Legendre's, whatever the procedure is. There's only one concept that you have got a differential equation. That differential equation is a linear differential equation with variable coefficients. Then it is transformed into a linear differential equation with constant coefficients. Please subscribe our channel Vibrant Institute of Mathematics and press the bell icon for the latest updates. आपको अगर हमारे वीडियोस पसंद आ रहे हैं तो जो लाइक है वो तो बनता ही है. तो ये जो है आज का टॉपिक, इस टॉपिक के साथ मैं कहूँगा हमारे पास पूरे जो लेक्चर्स अभी तक के जितने भी हो गए हैं वो डिफरेंशियल इक्वेशंस. That is the beauty. I say Legendre's हो या Cauchy हो या हमारे पास linear differential equation with constant coefficients. I say पूरे जो लेक्चर्स मैंने दे दिए. आज ये लास्ट लेक्चर था इस पैटर्न पे, मैंने सारा दे दिया. ये जो पैटर्न अगर कोई गेट वाला कोई स्टूडेंट होगा उसके लिए ये कैच करेंगे. यहाँ पर ये जो मेरे वर्ड्स थे इंपॉर्टेंट थे शॉर्टकट टेक्निक देखने के लिए, उसमें हम ओमिट कर सकते हैं, निकाल सकते हैं वो वैल्यूज चैन रूल या सारे बाय यूजिंग कंपैरिजन. दैट इज इट. थैंक यू वेरी मच.